Locating root of n on a number line. So we're looking at a general case. Same steps. Draw a line segment. Name it as AB. Measure and mark n plus 1. So if this is any point, the distance of n plus 1 is where you have the other point. Draw a semicircle of radius n plus 1 by 2. So basically, draw a perpendicular bisector, find the center. With that as a center, if you draw a semicircle, it will by default touch these 2 points. So with this in mind, from any one of these points, right, this point, this is what we're talking about, mark 1 centimeter inwards, cutting the diameter, right? At any side, doesn't matter. This is 1 centimeter away. And here we are going to draw a perpendicular. We'll call this as P, and this will be your Q. Your length PQ is root of n. So with that, with this length, we can project it onto the number line, thus satisfying or answering our question of finding the length or locating the root of n value on a number line. So this particular length is root of n. Okay, so now how it works, how is that we ended up with this answer? So first thing first, let me see, this is your diagram. This is generated by a Python code, and basically program has generated it. The computer has generated it. Okay, let me put it in the simplest word. It's a computer that has generated this. So basically, it's the same thing, is that this is an extra line. So this, I'll erase it off so that there is no confusion. Right? Okay, now let's start talking about it. So from one end to another end, this is n plus 1 by 2. Sorry, n plus 1. And from the mid of it, so somewhere over here, is your n plus 1 by 2. Oh, my bad, sorry. Till here is n plus 1 by 2. Right, this is the entire length. From one end of the circumference to the other end, passing through the center, is your diameter. And the radius will be obviously half of that. Now remember, this is 1 centimeter inward. That's what we have drawn. That's the logic. With this logic only we have done this. So this has to be 1 centimeter, that we are sure of. So the next question is, what is the length from this point to this point? Now pause and think about it. If I call this as OO, and this is point P, and this is N also, what is OP? We know O in length and P in length. Find this length for me. Okay, so please pause and try it out. I hope you guys have tried. So we have OP, which is equal to ON minus PN. So this is n plus 1 by 2 minus 1. Right? LCM is 2. So we have n plus 1 by 2 minus 2, the entire thing divided by 2. So n minus 1 by 2. So this is n minus 1 by 2. Now, if I join from the center to the circumference and name it as point Q, what is the length of OQ? From the center to the circumference. This is nothing but your n plus 1 by 2. Why? Because it's radius. So we know OQ We know OP. Now I'll draw this separately and you will get to see what we are trying to do. So let me do this. Right. This is n minus 1 by 2. You guys only found it. OQ is your radius, so n plus 1 by 2. And we have to find this length. Right. So as per our understanding, as per me, what I have told us is this root of n. But we are trying to prove that. So we'll go with in triangle OPQ as root of P is equal to 90 degree. OQ square is equal to OP square plus PQ square. So OQ is n plus 1 by 2, the whole square is equal to n minus 1 by 2, the whole square, plus PQ we have to find. So, okay, I converted to n. Yeah. Now what we have to do, use our exponent formulas, numerator square plus denominator square is equal to numerator square by denominator square plus PQ square. See, we need to ease this calculation. For that sake, I'm multiplying with 4. Okay. Right. I'm just multiplying with 4 with all the terms. There are 1, 2, 3 terms. So each term I'm multiplying and right is equal to 4 by 4. Again, all this is nothing but commutative law. So we are looking at cancellation, and that's it. So we have n plus 1 the whole square is equal to n minus 1 the whole square plus 4 pq square. Now expand this. So we have n square plus 2n plus 1 is equal to n square minus 2n plus 1 plus 4 pq square. So in both the sides we have n square plus 1 and plus 1 common. Like we can cancel that. This is not common because this is plus and this is minus. Altogether different things. So plus 2n minus 2n to left hand side will become plus 2n is equal to 4 pq square. So we have 4n is equal to 4 pq square divided by 4 both the sides. So n is equal to pq square. So pq is equal to square root of n. So many units. This was the whole idea, to prove that this length is root of n. And so from point P to this end, right, this entire length, or I can redraw here actually. This entire length is by default because this PQ is root of n and we are taking this P as a center and drawing a semicircle. So this length will be root of n itself, right? So this is kind of your proof. Not kind of your proof. This is a proof if they ask you to prove. If not, this is only mainly for your understanding, right? So pause and have a look. There's nothing much here. I've used one formula. A by b whole to the power of n is a to the power of n by b to the power of n. Okay, all these are basics. You need to be familiar with all of this. Please go to math basics, construction, exponents, fraction, addition, subtraction, everything is being done over there. Please understand those, only then you will improve with maths and you will find maths to be a lot easy. If not, explaining all of this small things in your higher grade is time consuming and it will just frustrate you because there's already so many concepts on that. If you're learning the basics again, it's not ideal. Okay. So pause and have a look.